Okay, now let's see how we can apply this particular example in this case. We have 5 PR is 60, then the value of R is what? So 5 PR is 60 means 5 factorial upon 5 minus R factorial is equal to 60. This is going to be 60. So what we can do is that we can do it this way: 5 into 4 into 3 into 2 upon 60 is equal to 5 minus R factorial, which is the same as 5 4s are 20. So this is going to be 120 by 60 is 5 minus R factorial. In other words, 5 minus R factorial is 2. If 5 minus R factorial is 2, which means that this itself has to be 2 factorial. That means 5 minus R factorial is 2 means 5 minus 3 factorial is what is 2 factorial, which means R is going to be 3, because if we substitute R as 3 over here, we get 5 minus 3 factorial 2 factorial, which is the same as 2. So that means R is going to be 3. Now in this case, expanding it as 5 minus R plus 1 and all makes no sense. You just have to think logically. 5 minus R, 2, we can even write this 2 can be written as 2 factorial. So 5 minus R factorial is 2 factorial, which means that 5 minus R is 2. Because if R factorial is M factorial, it means that R is equal to M. Simple logic. So 2 factorial can be written as, so convert both the sides to factorial. So we get 5 minus R is 2, and hence R is 5 minus 2, 3. And hence the value of R is 3. So, yes, and we do have it as 3. This is a simple way of solving an equation. Let's check what the next one we have is. NP4 is 12 times NP2. Then N is equal to what? So we are looking at N being equal to what? Obviously N cannot be minus 1 because it is a negative answer. So we can simply solve this clearly. So we have NP4 means N factorial upon N minus 4 factorial. And this will be 12 times N factorial upon N minus 2 factorial. So this gets cancelled. Now what we need to do is, now we can take this to this side. Now N minus 2 factorial can be written as N minus 2. The next one is going to be N minus 3. And the next one is going to be N minus 4 factorial. Because it's going to be N minus 2, N minus 3, N minus 4, N minus 5. And finally it will be 1. So the next one will be N minus 4. This is 12. Divided by N minus 4 factorial. So we have to see that the factorial based terms are getting eliminated. So what, obviously if you reduce 2, we get sometime N minus 4. So N minus 2 into N minus 3 into N minus 4 factorial. This gets cancelled. So if you open the bracket, you get N square minus 5N plus 6 minus 12 is 0. So we get N square minus 5N minus 6 is 0. If you solve it, this can be split up as N square minus 6N plus N minus 6 is 0. So we get either N as 6 if you solve it, or N is equal to minus 1. Now obviously we will discard away this value. If you remember, N is also always a positive. Both N and R are positive integers. So N has to be 6. So among these, this is the option that works here. So N is 6, and as we derived it, it is really 6. So much on similar basis, we have NP4, 20, NP2, right? So in this, we can eliminate this one and this one in any case. It cannot be minus 2. It cannot be minus 2 and 7. But let's form the equation. You get N factorial by N minus 4 factorial is equal to 20 times N factorial upon N minus 2 factorial. So this gets cancelled. This one cross multiplying, get N minus 2 factorial, which can be written as N minus 2 into N minus 3 into n minus 4 factorial upon n minus 4 factorial is 20. So we can just cancel this, right? So we can either solve this or maybe check that this is out of question, this is out of question, as we said, because both of them have one negative value. Maybe you could even check up with 7. 7 minus 2 is 5. 7 minus 3 is 4. 5 into 4 is 20. So among these, this is the right answer. So we could even proceed further by combination of eliminating and actual solving. So we end up getting n as 7. Yes, we do have it right over there. Okay. Then we have a case wherein you have np3 upon np2 is 3:1. So np3 is, now in this we can't eliminate anyone among them because all are positive. So n factorial upon n minus 3 factorial divided by n factorial upon n minus 2 factorial, which is 3 by 1, which will be eventually n factorial upon n minus 3 factorial into n minus 2 factorial can be written as n minus 2 into n minus 3 factorial upon n factorial is 3. So eventually this and this and this get cancelled and you get n minus 2 is equal to 3. So n would be 3 plus 2. 5. So we have only one possibility. So n is 5 in such a case. So we are basically, remember one thing, it's not minus 3 that has to be reduced, because n minus 3, the next stage would be n minus 3 into n minus 4. So you're going to make this less by 1. And we do have it as 5. Okay, now we have a slightly interesting case over here. We have m plus np2 is 56. And m minus np2 is 30. Now, in all possibilities, this is not possible because m minus np2 would make, if m is 4 and n is 4, you'll get 0 p2. It's like selecting 2 items out of no number of items, which is never possible to be 30 because it's an absurd situation. So it could be all probabilities this or this. So if you look at it, m plus np2 means m plus n factorial upon m plus n minus 2 factorial is 56. And here we have m minus n factorial upon m minus n minus 2 factorial is 30. Now this is nothing but, we can write this as m plus n into m plus n minus 1 into m plus n minus 2 factorial upon m plus n minus 2 factorial. If you see, m plus n is occurring, so you're reducing the bigger number by 1. M plus n is going to be bigger than this. So till you get, this part is getting cancelled, which will turn out to be 56. Okay, so we have m plus n minus 1 is 56, and this one, similar basis, we have m minus n into m minus n minus 1 into m minus n minus 2 factorial upon m minus n minus 2 factorial is 30. Now this can be written as, if you open this, we can take m plus n as a, maybe you get a into a minus 1, which is a square minus a minus 56 is 0. And this, if you solve it, you will end up getting a square minus, so a is 8 or a is minus 7, which we will discard this possibility. Same way, if you take this m minus n as a is equal to 8, which means that m plus n is equal to 8. Similarly here, if you take this as b, you get b square b into b minus 1, which is b square minus b minus 30 is 0. If you solve this, you end up getting b is equal to 6 or b is equal to minus 5. Discard this one. So b is equal to 6, which means m minus n is 6. If you solve these two equations, you get m is 7, 2m is 14, and n is going to be 1. So among these options, m is 7, n is 1. So this is how we solve this kind of a question. So this is how we can get this. All right. Let's move to the next one, and yes, m is 7 and n is 1. We have similar one over here. We can just form the equation and do it the same way as this is. Or we could substitute it and get it and check it up and see. Say for example, n is 6 and n2 is 6, n1. This is out of question because n1 minus n2 can never be 0. Maybe 10 n2, so you get 10 plus 2 p2, that is 12 p2. 12 p2 is going to be 12 into 11 into 10 factorial upon 12 minus 2, 10 factorial. And yes, 12 p2 is 132. So since it is satisfying, maybe we'll check up this. 10 minus 2, n1 minus n2, 10 minus 2, it's going to be 8 p2. 8 p2 is going to be 8 into 7 into 6 factorial upon 8 minus 2, that is 6 factorial. This is getting cancelled and you're getting 56. So definitely this is out of question. So even this is not possible. What about this? 9 plus 3, 12 p2. 12 p2 in any case is 132. And 9 minus 3, 6 p2. 6 p2 will turn out to be 6 into 5, 6 factorial upon 6 minus 2, 4 factorial. So it's 6 into 5 into 4 factorial by 4 factorial. So it is 6 into 5, 30. So we see that n1 is equal to 10, n2 is 2, satisfies this equation but not this. And n1 is 9, n2 is 3, satisfies both this equation and this. So we can, the previous example I did by actual solving, and you can at times, depending upon the time availability, you can even do by actual substitution. And of course remember that cases like these where n1 is 6, n2 is 6 have to be totally eliminated because n1 minus n2 cannot be 0, nor can it be, and it cannot be lesser than 2. So hence we have a case. So among these, n1 is 9 and n2 is 3. Okay, so that's how we are solving this. Okay, then you have NPR, n into n minus 1 into n minus 2 into n minus r minus 1. How many factors do we have? The number of factors will be the number of terms that you're selecting. So number of factors is always going to be r. There will be r factors because you're picking up r out of n. So there is going to be r factors. Just as you're selecting 10 books, 3 books out of 10, there will be 3 ways in which you select. So it's going to be 10 into 9 into 8. So there are 3 factors, much the same way. There is no need to calculate anything. It is understood there is going to be r factors in such a case. Okay, yes, and we are right.